Now we're going to define three new functions, the so-called hyperbolic functions. That's hyperbolic cosine, hyperbolic sine, and hyperbolic tan. Sometimes pronounced cosh, sinh, and tanch. So we'll define the hyperbolic cosine function, or cosh, as e to the power of x plus e to the power of minus x divided by 2. That's just a definition for the moment. Hyperbolic sine is going to be e to the power of x minus e to the power of minus x, also divided by 2. And hyperbolic tan is going to be defined similarly to regular tan, in that it's going to be hyperbolic sine of x divided by hyperbolic cosine of x. So this is similar to the way we define regular tan as sine divided by cos. Hyperbolic tan is hyperbolic sine divided by hyperbolic cos. So there's a quick plot of those three functions with cosh in green, sinh in red, and tanch in blue. Now we're going to work out a few identities for these functions. You might recall from sine and cosine that sine squared x plus cosine squared of x is always 1. For the hyperbolic functions, we're going to look at cosh squared of x minus sinh squared of x. And let's see what that is. So for the hyperbolic functions, it's minus sinh squared instead of plus. So let's substitute in our definitions from the last page. So cosh squared of x is cosh of x to be squared, and similarly for the hyperbolic sine. So we can put our definition straight in there. That's equal to e to the power of x plus e to the power of minus x over 2 to be squared, minus e to the power of x minus e to the power of minus x over 2, also all squared. So we multiply this all out. The top squared over the bottom squared. That top squared is e to the power of x times e to the x plus twice e to the x times e to the minus x plus e to the minus x times e to the minus x. And of course it's all over 4, which is 2 squared. Then we have minus, on this side, it's e to the x minus twice e to the x e to the minus x plus e to the minus x and e to the minus x, again all over 4. So now we just add all those up. It's all those terms on the top divided by 4, where e to the x times e to the x is e to the power of x plus x, or e to the power of 2x, and the same with the e to the minus x. Then we add those up, and the e to the 2x cancels with the minus e to the 2x, and the same with the e to the minus 2x, and we're left with that. Those 4's cancel, and we're just left with e to the x times e to the minus x. So we multiply the same number with different powers, we add the powers. So it's e to the power of x minus x, which is e to the power of 0. And anything to the power of 0 is 1. So that's an identity for hyperbolic sine and cosine functions, where we have that cosh squared of x minus sinh squared of x is equal to 1 for any x. Now, if y is equal to sinh of x, then what is the derivative, dy dx? Well, let's go back to the definition. Sinh of x is e to the power of x minus e to the power of minus x divided by 2. In order to differentiate that, I'll just break it up into two separate fractions, like this. And then differentiate. Dy dx is equal to, well, the derivative of e to the power of x is just e to the power of x itself again. That's actually where we get that number e from. On the right hand side, we use the chain rule to get the derivative of e to the power of minus x is equal to minus 1 times e to the power of minus x. And that half is still there, and the minus in front. Now we just tidy all that up, and we get a half e to the power of x plus a half e to the power of minus x. So we can take out that half again and say that that's e to the power of x plus e to the power of minus x all over 2, which is exactly the definition of the hyperbolic cosine function of x. So we have that the derivative of the hyperbolic sine function sinh of x is equal to the hyperbolic cosine function of x, cos x. So what's the derivative of the hyperbolic cosine function? Well, we get it in the exact same way. So try pausing the video and have a go at this one yourself first. It's exactly the same as the one for sinh of x. We do exactly the same. We say y is equal to, we put in our definition for the hyperbolic cosine function, we split it up into two fractions, and then we differentiate. And we end up with e to the power of x minus e to the power of minus x over 2, which is nothing other than the definition for the hyperbolic sine function. So now we've established that the derivative of the hyperbolic cosine function of x is equal to the hyperbolic sine function of x, and that the derivative of the hyperbolic sine function of x is equal to the hyperbolic cosine function of x. So this is similar to what we had with sine and cosine, where we had that the derivative of ordinary sine of x was equal to cos, and the derivative of ordinary cos was actually equal to minus sine. So it's a similar thing with the hyperbolic sine and cosine, except that each one differentiates and becomes the other, whereas with normal cosine that becomes minus sine. Let's look at another identity. Cos of x plus sinh of x. So try that with yourself and see what it comes out to. If you substitute in those two definitions and add everything up, you should find that it comes out to be just e to the power of x. What about cos of x minus sinh of x? I'll do this one for you quickly. You can see that it comes out to be just e to the power of minus x. So we have cos x plus sinh x is e to the x, cos x minus sinh x is e to the minus x. Now let's ask, what if we take the cos sinh or tan, hyperbolic cos sine and tan, of minus x? So for example, if it turns out that hyperbolic cosine of minus x is the same as the hyperbolic cosine of x, then that function would be symmetric around the y-axis. So let's substitute in our definitions and see what we get. Well, cos of x, you should note by now, it's e to the power of x plus e to the power of minus x divided by 2. So cos of minus x is equal to e to the power of minus x plus e to the power of minus x divided by 2. Well, that e to the power of minus x is just e to the power of plus x. So we have this. Now it doesn't matter what order those top two terms are in. If you look at the definition from cos of x, that's exactly what we have. So that's equal to cos of x. So we actually have that the cos of minus x is equal to the cos of x. So if you start at x equal to 0, it doesn't matter if you go in the positive or negative x direction, the function looks the same both ways, meaning that it is symmetric around the y-axis. If you look back at the plot of the function on the first slide, you see it looks something like that kind of a shape. And is symmetric there around the y-axis, or the cos of minus x is equal to the cos of x. What about sinh of minus x? Well, sinh of x is equal to e to the x minus e to the minus x over 2. So sinh of minus x would be equal to e to the power of minus x minus e to the power of minus x over 2, which will be equal to e to the power of minus x minus e to the power of x over 2. Now that directly doesn't look like the definition of sinh or cosh. But if I take out a factor of minus 1 here, I can say that that's minus 1 times minus e to the power of minus x plus e to the x over 2. Or if I tidy that up, that's just equal to minus, that's that minus 1 in front. I'll swap these other two terms, e to the x minus e to the minus x over 2. Now this piece here is exactly the definition of sinh of x. So what I have there is actually just minus sinh of x. So we have that sinh of minus x is equal to minus sinh of x. Now that means that around the y-axis, this function is what you'd call anti-symmetric. That means that going left or right of the y-axis is the same thing, but just with the opposite sign. So if you go back to that first plot of the hyperbolic sine function, you'll see that it looks vaguely like this. So that's an example of what you'd call an anti-symmetric function. Finally, what about the hyperbolic tan of minus x? Well, hyperbolic tan of x is equal to hyperbolic sine over cosine. Just like how regular tan is regular sine over cosine. So tan of minus x is just equal to sinh of minus x over cosh of minus x. And we already know what sinh of minus x is and what cosh of minus x is. So we can just substitute those in. Sinh of minus x is minus sinh of x, and cosh of minus x is just cosh of x again. So if we look at what we've got left, it's just minus tan of x. If we look at the definition above. So we have the tan of minus x is equal to minus the tan of x, another anti-symmetric function. And if you look back to that graph at the start, you can see that it looks anti-symmetric. It looks like something vaguely like that. So again, if you go to the left of the x-axis, it looks the same as going to the right, but flipped upside down. It's minus it. Finally, if I have a function y equal to hyperbolic tan of x, what is the derivative, dy dx? Well, as before, we put in our definition for tan of x, which was sinh over cosh, and then we use the derivatives that we've already got for those to get the derivative of tan x by using the quotient rule. So we let that equal to u over v, where u is equal to sinh of x and v is equal to cosh of x. Well, if u equals to sinh x, then du dx is equal to cosh x. And v is equal to cosh x. That means that dv dx is equal to sinh x. Then by the quotient rule, we have that dy dx is equal to v times du dx minus u times dv dx all over v squared. So let's substitute in. V is cosh of x. Du dx is also cosh of x. Minus u, which is sinh of x, times dv dx, which is also sinh of x. All divided by v squared, which is cosh of x squared. So on top we have cosh squared of x minus sinh squared of x, and at the bottom we have cosh squared of x. So cosh squared of x means cosh of x then squared, and the same for sinh of x. So we have that. Now from before, if you look at the previous identities we went through, we know that cosh squared of x minus sinh squared of x is just 1. So we have that the derivative of the hyperbolic tan function is 1 over the hyperbolic cosine function squared, or if y equals tan x, dy dx is equal to 1 over cosh squared of x. So that is the hyperbolic sine, hyperbolic cosine, hyperbolic tan functions, sinh, cosh and tan, and some identities to do with them and each of their derivatives.